So Pascal's law, you might see a diagram like this. It's just a pipe, basically a U-shaped pipe, okay? And the idea is if you had, let's say, fluid in this pipe and you have a piston right here and another piston right here, basically it's just an object obstructing the pipe with a halfway decent seal on either end so that the fluid can't get out. Pascal's law simply states that, hey, with whatever amount of force you push on this side, it's going to push up on this side with the same force. Does that make sense? So an applied force on one side of a fluid will be the same on the other side of a fluid as long as the diameter and everything's the same. Okay? This, by the way, is the way your brake system works in your car. So when you push on the brakes, it's going to go to the master cylinder. Of course, you've got a brake booster first where it amplifies your pressure, usually using the vacuum of the engine. So it boosts the pressure you apply to the pedal with. And then the master cylinder pushes, and that pressurized fluid now is applied to each one of your brake cylinders on your actual rotors or drums, whatever you have on your car, okay? So Pascal's law is the principle behind that, okay? Now, did Pascal invent that? No, he just recognized that phenomena. In your house, you do have a version of that. I need to start over my drawing here. Let's see. A sink. I'm not going to draw the faucet, but I want you to draw the sink here. And we can have a nice little drain. Maybe you've got the pop-up type. Maybe you got the pop-up type, right? And then that goes down and comes to an elbow or a U-shaped looking thing. A what? Oh, it's you. Yeah, it's the trap. No helping. So you've got a trap, it's called. Okay? That is a trap. And then out the other side, you've got another elbow. Okay? And that's going to feed into an extension. That goes into another pipe. That's got an elbow. That goes down your wall, inside, usually your wall, or it might be in the floor. And that heads out, the water would head out to your sewer line. Or if you've got a septic system at home, it'd go to your septic, okay? Now, I'm going to switch colors to blue. So your water drains down, gravity pulls it down, and it's going to start to fill up the trap, okay? Once it gets to about here, the level fills up to here, and now it starts to spill out. Everybody see that? Osborne, you see that? Okay. So once it starts to spill out, it can go down to the septic. You stop draining water, the level would come back to be, right about here. Everybody follow? Mm-hmm. Falling asleep, but following, okay? Why not just have it go straight out? Wouldn't that be less obstruction? Wouldn't the water flow easier if you didn't have this trap here? Why are we trying to trap water here? And I'll accept two answers. This is called wait time. In education, you wait. Somebody knows or your tub. In your toilet, there's a trap. You know? Some of these traps, if they're glued in, you might have, let me switch colors again. You might have what's called a clean out. So you'd have a little cap, a little plug that you can turn out, and what happens if you pull that plug? The water drains out, but, Why do you have a plug on the bottom of your trap? in case it gets clogged, okay. Has anybody ever known someone that lost something down the drain? What did they lose down the drain?
I lost the back of my ear.
Your earring, the thing that retains it, the earring retainer. Okay, anybody else? I thought I saw another hand. What they lose? The cap, the toothpaste? Okay. How about the stone from a ring? There have been a lot of people through the ages that have lost, like the what are they called? The prongs that hold the diamond in place get loose over time, and the diamond falls out while they're washing dishes or something. And if it's glued in, if the trap is glued in, you can take that clean out if you have one out, and bloop, might fall right into your bucket. Because a diamond is dense, right? So it's not going to get flushed out real easy. So it'd stay there in the trap. So that's one good reason to have a trap. But that's actually not the primary purpose of having a trap. What? What does it say again? Sewer. How does sewage smell? Okay, so what's to stop? Have you ever smelled sewage in your house? If you have, you might have had a dry trap. If you don't use a sink for a while, or a shower, tub, whatever, over time the water can evaporate low enough that the gas can get through. And now all of a sudden, especially when there's a good pressure differential, like storm comes or whatever, you can have that gas pushed right up through your sink.
Because you'll have a pipe that goes out the top.
Yep. Yes, you should have, on most of them, you'd have a vent pipe. So the gas can escape this way, and it wouldn't be able to get through here because you've got water trapping. The water's not what's getting trapped, really. We want the water there to trap the gases back here. Does that make sense? So you're trapping the water, sure, but it's meant to trap the gases back. Okay, but that principle's still there, right? The more water you put in here, it just pushes out the other side with the same amount of force. But yeah, your sink.